Hello students, today we are covering lesson 10.3 on experimental and theoretical probability. Please follow along in your textbook on page 414. I would like you to copy down the key idea on page 414. Experimental probability. The probability that is based on repeated trials of an experiment is called experimental probability. So the probability of an event equals the number of times the event occurs over the total number of trials. So in class, when we've conducted different experiments, we show that the experimental probability. So take a moment to copy this down. Example 1 is finding an experimental probability. It says the bar graph shows the results of rolling a number cube 50 times. What is the experimental probability of rolling an odd number? So in this case, we have, again, our formula. The probability of an event is the number of times the event occurs divided by the total number of trials. So for this event, we are hoping for an odd number when we roll the cube. So we are looking for the probability of an odd. And if you look at the chart here, it shows you the number of times we rolled the number, and here it shows the number that we rolled. So I'm going to look at the odd numbers only, so 1, 3, and 5. So we rolled a number 1 10 times. We rolled a number 3 8 times. And we rolled a number 5 11 times. So when I add them up, we rolled an odd number 29 times. So the number of times that the event of rolling an odd occurred is 29. Now the total number of trials, it says in the information above that we rolled the number cube 50 times. So it's 29 over 50. That's the probability. And so when we find the experimental probability, we can write it one of three ways. We can write it again as a fraction. We can divide the numerator divided by denominator and write it as a decimal, which would be 0.58. Or we could write the decimal as a percent, which is 58%. I'm okay if you want to use a calculator for this activity to calculate the different percents or decimals for probability. Okay, moving on to example 2, making a prediction. It rains 2 out of the last 12 days in March. If this trend continues, how many rainy days would you expect in April? So this time, our probability is looking at the rain in April. Now, we don't know the number of times it happened in April, but we do know the number of times it happened in March. It rained 2 out of 12 days in March. And so when we reduce this, it becomes a 1 over 6 probability. So 1/6 of the days it rains. Now, if we want to predict how many days it will rain in April, we see on the calendar there are 30 days in April. So we're going to take our probability and multiply it times the number of days we expect. So we can take 1/6 times the 30 days in April. And when you multiply, you get 30 divided by 6, which equals 5, or 5 days. So we can predict that there will be rain for about 5 days in the month of April. Right now, I'd like you to try on your own numbers 1 and 2. In example 1, what's the experimental probability of rolling an even number? So please go back to example 1. We conducted the experiment for odd. Now you go back and do it for all the even numbers. Then on your own number 2, at a clothing company, an inspector finds 5 defective pairs of jeans in a shipment of 200. If this trend continues, about how many pairs of jeans would you expect to be defective in a shipment of 5,000 pairs? So go ahead and give that a try. Okay, now I'd like you to write down the key idea on page 415. This time we are looking at theoretical probability. When all possible outcomes are equally likely, the theoretical probability of an event is the ratio of the number of favorable outcomes to the number of possible outcomes. So here's our formula that I'd like you to write down as well. Probability of an event is number of favorable outcomes divided by number of possible outcomes. Take a moment to finish writing this down. Okay, example 3, page 415. You randomly choose one of the letters shown. What is the theoretical probability of choosing a vowel? So we're looking for the probability of a vowel. So if you look back at our key idea, the number of favorable outcomes. So our favorable outcome is a vowel. There's 1, 2, 3 vowels. So 3 favorable outcomes are vowels out of the total possible outcomes. So there's 1, 2, 3, 4, 5, 6, 7 blocks total. So 3 out of 7 would be our probability. Now you can also show this as a decimal. As a decimal, it'd be 0.43. And as a percent, you multiply the decimal by 100 and you get 43%. Example 4 is using a theoretical probability. The theoretical probability of winning a bobblehead when spinning a prize wheel is 1/6. The wheel has 3 bobblehead sections. How many sections are on the wheel? So we have the formula. The probability of our event here is the bobbleheads. And here you have the number of bobblehead sections divided by the total number of sections. So they give us the probability in this equation. So we know the probability is 1/6 chance. They also tell us the number of bobblehead sections. It says that there are 3 bobblehead sections. So we know the numerator. What we are trying to solve for is how many sections are on the wheel. So we're looking for the total number of sections. Since we don't know that, we can call it S. Now, there are a few ways to solve this. One of the easiest ways is to look for a common multiplier. 1 times a number makes 3. So I know 1 times 3 will give us 3. Keeping that proportional, 6 times 3 will equal 18. So that means the number of sections will be 18 total sections. So there are 18 sections on the wheel. Now I'd like you to try on your own numbers 3 through 5. Tell me what is the theoretical probability of choosing an X in example 3. Number 4, the theoretical probability of spinning an odd number on a spinner is 0.6. The spinner has 10 sections. How many sections have an odd number? You can change this decimal into a fraction if you think that might be easier for you. Number 5, the prize wheel in example 4 was spun 540 times at a baseball game. About how many bobbleheads would you expect were won? So go ahead and work those 3 out. Example 5 is comparing experimental and theoretical probability. And this is page 416. So it says the bar graph here to the right shows the number of times rolling a number cube, and it says you rolled the cube 300 times total. So if we were to add up all the sections, it would add up to 300. The number of times rolled is on the left. The number that you roll is on the right, or the horizontal. So it says, what is the experimental probability of rolling an odd number? So we're going to look at the odd numbers, 1, 3, and 5. This is very similar to the other example we completed. So we have to go ahead and add those up. I'd like you to use your textbook to work out this example because we are running short on time. So work that out and we'll go over it in class tomorrow. Here is on your own number 6. Go ahead and pause the video to complete number 6. And last, go ahead and complete 1 through 9 in your rap journal. I hope you have a great day and I'll see you tomorrow. Bye-bye.